All right, good evening, everybody. Thanks for making time out here. I hope this is really helpful. This is going to be the last one of the semester. I'm sure you're going to be happy about that because finals are coming up, which means everybody gets to go to home soon. So that's really exciting. And we're going to cover a couple, just kind of give you an opportunity to review, kind of go back into the idea of dynamic programming and how you can use that to build up solutions, as well as being able to do some recursion as well. Before we do that, our last guest speaker of the semester is Vinny Karanja. So Vinny has, as you probably overheard us chatting, has just accepted a position with Microsoft and will be starting there once he graduates in May. And so congratulations, FanCon gives you congratulations with the applause there. So that's tremendous. And well, I would like to give Vinny the floor and give him the opportunity to talk about his experience as a Notre Dame student, kind of how he started out here and he has a really good background of experiences that are really diverse and getting to work in foreign countries, teaching English languages and having opportunities to do internships. And he was in the first class I ever did a pre-turnship in with the VLSI, and he's talked a bit about how that's impacted and helped his job search. Since you all are well in the thick of the pre-turnship right now, it'll be good to hear what Vinny has to say, because that can potentially show you paths towards getting really good positions based on the work you're doing right now. So on that note, I am going to step out of the way and I'm going to let Vinny do his thing.
Awesome. I actually made a slide deck to.
Sure. Hold on. Let me allow you to share the screen then.
Awesome. Thank you. All right.
You'll be able to now.
All right. Let me go ahead and share my screen. Okay. Perfect. Share. And can everyone see my screen?
Yes, I can.
Perfect. Okay. So yeah, like Professor Morrison said, my name is Vinny Karanja, and I made a slide deck and basically just talking about my journey to Microsoft. So the background of this, obviously it starts with Notre Dame up at the top left, and then all the places that I've just been to as a result of studying computer science as a Notre Dame student. So these are the countries or the cities that I've been to like in the past 4 years, all thanks to Notre Dame and thanks to the computer science department. So let's go ahead and start. So like any good coder, this is my Who Am I page. So my name is Vinny Karanja. I was born in Kenya and I moved to America when I was about 4 years old. And I have I have a huge passion for language. I've always loved languages, and I've always just had kind of like a knack for language acquisition. And I've loved speaking to people, and just I've loved how languages, connect and also like divide people. That bleeds into kind of why I started studying computer science in the first place. Obviously, in computer science, you learn a lot of coding languages, but also in computer science, you learn a lot about how things work. And for me at the time, I wanted to learn about natural language processing. And so that's kind of what got me into computer science. And ever since then, I've just like fallen in love with it. I was in the Kellogg International Scholars Program my sophomore year, that's called KISP. And while I was there, I was still, very, very infatuated with languages. So my research with the Kellogg International Scholars Program was about language acquisition and how it affects refugees moving from Africa to Europe. And then the last bullet point here is on my ISSLP. And so that's a service program that Notre Dame has. So I was fortunate enough to be one of the scholars selected to be a part of this program. And so I spent my summer after sophomore year working in Panama, teaching math at a high school, as well as English too. All right, so just a quick overview of these slides. So I'll take you guys on my Notre Dame journey, and then I'll go over some important classes. Then I'll talk about my summers, and I'll talk about interviews, and then I'll leave it I'll give you guys the floor to ask any questions you have. So my Notre Dame journey actually started over here on the top left in Boston, Massachusetts. I went to a school called St. Patrick's, and it was taught by Sisters of Notre Dame. So kind of from a young age, and at this point I didn't really know, but from a young age, the universe, I guess, had just been planting like little Notre Dame seeds in me. At the bottom of that picture is a picture of Tacoma, which is the city in which I live now. It's in Washington. And there, here at the top right, you'll see a picture of my high school. And that was where I met a lot of people who had parents or just like who knew of Notre Dame and who would always like speak highly of Notre Dame. The year before mine, so the class of 2016, the three people decided to accept their acceptance into Notre Dame and matriculate. So Notre Dame, so there was just like the universe again planting Notre Dame seeds in my brain, and then eventually I decided to go and I got in and I lived in Morrissey, which is the picture here on the bottom right on the left hand side, and then there's a picture of the dome. All right, so my Notre Dame journey actually is kind of weird. So before I got into computer science, I came in as an arts and letters major. So I was in the College of Arts and Letters for a while. And then I was in the College of Science. And then finally, my sophomore year, I transferred into the College of Engineering. So I was constantly going from college to college, just looking for something because, like I said, I knew that I wanted to do something with languages, but I kind of didn't know what I wanted to do up until I discovered computer science, natural language processing, et cetera, et cetera. So now I'm going to go into important classes here in the computer science curriculum. The first one being fundamentals of computing. I trust that you guys know why these classes are important because all classes are important. So I'm going to talk about other things that that might not be known. So for example, I think that Fund Comp is one of the most important classes I've taken because it was the first computer science class I took. And it being the first computer science class I took, I was kind of thrown into a whole new world. I didn't know much about coding, like how coding worked. I was kind of just, I just knew that I liked this one topic and computer science had something to do with it. So I decided to dedicate the next, the better half of my Notre Dame career studying something that I didn't know much about. And so the first exam I took in computer science I actually failed, and I failed it horribly. It was the first exam that I failed in college. And I went to Professor Ramsey, who teaches fundamentals of computing, and I talked to him, and he was like, don't worry about it. A lot of people fail exams. It's not the end of the world. Blah blah blah. And at this time, I had never failed an exam before because I wasn't really familiar with the wrath of the College of Engineering at the point. So he really comforted me and just assured me that everything would be okay. And so I believe that that's why fundamentals of computing is an important class, just because it's one of those classes where you learn a lot, not only about the major, but also about yourself and also about your strengths and weaknesses, and also about like how to deal with failure, which will be important later on in this slide. So the next class that I find really important is discrete. And just because discrete is just one of those classes that teaches you how to just how to be an academic in computer science, it teaches you like the lay of the land almost. You learn about trees and you learn about, different types of algorithms. And it's one of the most important classes, I think, because it prepares you for interviews, but most importantly, it prepares you for data structures and classes that build up off of the concepts that you learn. The next class is logic design, and I think that logic design was an important class just because, also like Fund Comp, logic design was one of those classes that I think teaches you the importance of just like always trying. Like for me, I had a hard time in logic design just because it was something complete. It was we were coding in Verilog, although Verilog isn't a coding language, but we were using Verilog to program, and I just did not have any experience with programming hardware. And to be honest, I also didn't really find it interesting. So it was one of those classes that just taught me that, just the importance of being able to find something interesting about something that you don't think is interesting, and just giving yourself motivation to do something, and making something that seemed at the time really, really boring, to be brutally honest, and turning it into something that's fun and something that you can do. Um, so yeah, so that's why logic design is up here. And then systems played an important role in my journey to Microsoft, I think, because it basically it was one of those classes that kind of just like breaks you down, but then like slowly builds you up and gives you a lot of confidence, and it teaches you just the importance of not giving up and resilience. And then last but not least is data structures, and I'll talk the most about data structures. So data structures, I believe, is the one of the most, and if not the most important class I've taken here at the University of Notre Dame, just because it not only teaches you, well, it's already an important class because it's data structures, but the way that it's taught here, I think, is very unique in comparison to what I've heard from my friends at other universities, because not only do you learn how to, code a tree, for example, or how to traverse or how to implement different algorithms, but you also learn the importance of being able to articulate why you use certain methods or why you use certain data structures. And that played a very important role in my career path and in interviewing. Also, the VLSI course that I took, which was also taught by Professor Morrison, I put there as an important course to take, just because that's where I learned that your path is not just it's not binary. In previous classes, we'd kind of been told, or from example too, from upperclassmen, we'd seen that after you graduate computer science, you either go into software engineering or you go into consulting, and that's kind of it. But with VLSI, we were able to do a pre-internship project, and when we did the pre-internship project, it exposed you not only to various industries, but also into various roles in industry that rely heavily on a technical background, but aren't necessarily what you'd call like your like average technical jobs. For example, project management, program management, product management, those types of positions. And so I think that VLSI was a very important course in my career development path because it exposed me to that. And then so now we'll go into my summers. I'll talk to you more about my summers. So my summers have been pretty unconventional. So at the top right is a picture of Nordstrom. That's where I worked after my freshman year. And I did retail there, and it was just like a normal summer job. And then my sophomore year, here is a picture on the left, is where I went to Panama, and I stayed there for 4 months and I loved it. And then my junior year, so the summer that just happened, here on the bottom right, I had an internship with a startup called Eventually, and I was a program manager for that. And it was quite the fun time. And I never really had a like conventional summer or a conventional internship like path, just because a lot of people typically will intern like at a big firm over the summer or something. But I've always been a little picky about the jobs that I wanted, and I'll talk about that more when I talk about interviews and rejections. And I think it was Professor Morrison would always just talk about the importance of knowing like of choosing happiness over like a big like fancy career or over um like basically happiness over money, and just like telling us the importance of like the story that you shared with us, Dr. Morrison, about getting offers from all these big companies, but you chose instead to become a professor. So that played a huge role in my decision to teach in Panama instead of working for a company over the summer, just because it would have been great and I would have made a lot of money, but I knew it wasn't really something that I wanted to do, and it wasn't really something that I'd find fulfilling. So my summers have I've always made the choice of doing what I think will be more fulfilling, because that's what I've learned at my courses here at Notre Dame, and that's what I've learned to place importance on. And then my last slide is about interviews and rejections. So I've interviewed with a lot of companies, and like I talked about before, I've been rejected from, and I've rejected lots of companies too, just because I've rejected them just because after a lot of reflection and after a lot of introspection on what I wanted to do with my summer and what I wanted to do with my life per se, I just never found them, or I just didn't think that they would be as fulfilling as the other choices that I decided to make. The most important one of these companies, obviously, is Microsoft. And my journey with Microsoft is a pretty unique one, I'd say. So this summer, they reached out to me over LinkedIn and asked me to apply for a job and basically to interview with them. So I did that, and I went through the interview process. And then in the beginning of October, I had my final round interview. And a couple of days later, I got the big news, and they told me that at the moment, they did not have a job for me. They told me that I was still being under consideration, but they just weren't sure whether or not they could hire me at the time being. And to be honest, that had crushed me a lot, just because it was something that I wanted. It was something that I wanted a lot, and it was something that I'd hoped and prayed for. But my big tip, I guess, and the big way that I think that I was able to overcome this was I just never gave up, and I was like very insistent on keeping communications open with my recruiter, with everyone that I had met, and just constantly, like making myself known kind of at the company. I wrote letters actually to every single person who had contacted me about anything at Microsoft, and they were just thank you letters and saying like thank you so much, explaining to them like how important this company is to me, and telling them like how much it means to me. And the day after the day after I sent my last thank you letter to the last person, was when I got the news that I'd received an offer. And I think that that played a very important role in when it came to receiving this offer. And so from that experience, I just learned the importance of like not giving up. And that's kind of something that has played a huge role in my computer science journey, from all the classes that I talked about earlier and all the experiences that I've had. The one big common denominator that all those courses have is they're really, really difficult courses. They kind of like destroy you a little bit, but the overall importance is to not give up and to just keep going, because the path gets brighter at the end. And so when I heard this news from Microsoft, yes, I was hurt, but I knew from like previous experiences and that I've had with other courses, just nothing good has ever come from not working hard and like not pulling yourself up by the bootstraps and fighting for what you want, and whether it be a grade or whether it be a job. So I just knew that in order to achieve the goals that I wanted, I had to do something extremely outstanding. and do something that, you know, isn't really talked about or isn't really conventional. So I wrote letters to literally every single person that contacted me, and not just my recruiters, but even the person who contacted me to tell me but that my interview was starting in 15 minutes. Even that person, they only sent me one email. But, you know, just the importance of writing them a personal letter and telling them thank you so much, I think really struck a chord with them. And I think it really showed how, it really showcased a different side of my personality that is an asset to the role that I'll be working in. And I think that that really influenced them into making the decision to finally give me an offer. And now I'll give you guys the floor to ask any questions that you have about anything that I just shared. And yeah.
Well, first of all, Vinny, thank you very much for that. That was really awesome. First, we have the first comment from Fang Kong. He says, I am also a manner. And so the couple of things I want to follow up on that I kind of tell everybody as part of the pre-turnship. One of the reasons why I always say, like, well, okay, well, here's a really nice way to send a professional email, and here's a good way to reach out and kind of learn how to make that communication, is because a lot of times if they're trying to make a decision between two different people and one person kind of hasn't sent any emails at all, and the other person has sent really nice thank you notes to everybody, they're like, oh, well, that seems like a person who really enjoyed the interview. And if it comes down to a tie, that's putting you in a good spot. Another thing I was telling Vinny as he was going through the wait with Microsoft is that if they're telling you that they don't have a spot for you right now, and this is any company, one of the big things that's going to be really helpful for you is understanding that sometimes if they're saying we don't have a spot for you right now, that means they really like you and they have to figure out how to justify how to put money in your pocket. And that's what was going on with Vinny there, is that they were trying to find the funds to make sure that they could hire him and keep him around. So that's what ended up happening with Vinny there. So it's always a good idea to kind of just make sure, if you have and that's one of the most common questions, if I have a place I really want to work, how can I stand out? And one of the things is, you know, if you get an interview, your foot's in the door, don't let them close that door. You know, always send them polite emails. Don't be, there's a saying, squeaky wheel gets the grease. You know, don't be obnoxious about it, but at the same time, you know, for those of you who've been in the pre-turnship groups where the mentor might not have responded, I gave that little tip that I have about, I send the same email, but then I have that little line that says, I want to politely push this to the top of your stack. And they always say, like, oh, invariably, like, oh, I'm so sorry, I missed it. And it's really polite, but also it's a really good way of kind of letting people know that you're interested in the job. The other thing that Vinny touched on that's really important is happiness over money, right? You know, when you start paying your own bills and you start getting a certain amount of money, what you'll learn is that money doesn't necessarily translate into being happy, right? Now, don't get me wrong, I'm sufficiently compensated in my current job, and I'm quite happy here. But it also matters that my wife grew up in Indianapolis. That helps out quite a bit. I had really good relationships with a lot of the faculty here. So when they had come around about 2 years before, and I had just started at Ole Miss, and I don't think that's too appropriate leaving after a year and a half, and that turned out to be the right answer. And the second time they came around, I was much more eager to leave. And one thing led to another, and here I am. So I'm really happy for Vinny. I think that's really great. And the thing I would say to you, all of you who are here, is when you're interviewing, don't forget that you're interviewing the company too. You didn't go to Notre Dame so that way you could take the first job that was offered to you. You went to a place like Notre Dame because you want to be in the best position in the that tailors to your strengths. you know, Vinny's really passionate about languages, and now he's in a position where he's going to be coordinating with people, and he has to use that gift on a daily basis. You know, you have to figure out what it is that you're good at, but also, is this a good place to work? And if it's not, or you don't think it's a good fit, there's no problem in saying no. If it's just like, okay, I had an offer, I've turned them down, and you have to find the best fit for you as well. Don't get desperate because it's a brand name. Like if you're really interested in a specific company like Vinny is with Microsoft, and you think it's a great fit, and I think Microsoft and Vinny are a good fit, by the way. I think he's made a good decision there. But if that's something that, if you're trying to figure it out, don't get sucked in by just the pure brand name. So I said on the pre-turnship, don't fall for like a brand name. Look for the thing that you like. That's something that's going to help you out big time when you start looking for an actual work. All right, so on that note, I'm going to quit rambling and see if anybody in here has any questions that they'd like to ask Vinny. All right, so Fang Kong asks in the chat, Vinny, did you have any NLP experiences, project research at Notre Dame? Do you have any recommendation for a person who is interested in NLP?
So with natural language processing, I quickly learned that though it, you know, is an interesting thing, it just wasn't for me. And I learned that by actually talking to a professor who teaches natural language processing here here on campus. I think his name is Professor Chang, I want to say. Yes. Mm-hmm. Yes. And you know, I learned pretty quickly that it was an interesting topic, but I didn't want to go into it because it involved a lot of linear algebra and a lot of like concepts that I just honestly, to be completely honest, didn't like. And I think that I liked it because I liked the idea of natural language processing, but then once I learned about like what it really was and machine learning and everything like that, I quickly learned that that's not what I wanted to do. And it also helped that at the same time, I was taking the VLSI course and I'd been learning more about project management. And I'd been learning more about other things that you can do with computer science that interested me so much, just because they touched on, you know, like Dr. Morrison said, like on my other gifts that I appreciated. So yeah, so that's kind of my journey. But Professor Chang is a great person to reach out to. And same with Professor Niemeyer. He might know some people just because he does a lot of machine learning things and neural networks and things like that.
Yeah, so we had a brief chat while you were talking here. So he was talking about Dr. Chang. And Fang Kong, when you're able to make it to campus, you ever swing by my office, Dr. Chang's office is right next to mine. So you can always just hop right over there and work on projects. And that's another thing that's really good. If you're really interested in the software engineering side or the research side, getting into an undergraduate research project is really helpful. And I know that David Chang is very interested in looking for undergraduates. So he's passionate about that. So that's if you're really looking for NLP, you have a really good professor in that area. Okay. So does anybody have any other questions? Okay, well, in that case, Vinny, thank you so much for spending your time in that really nice PowerPoint presentation. Cool deal. All right, so so in Fang Kong, got some applause here as well. So in that case, what I'm going to do is I'm going to go through the last two of the PowerPoint slides here for these two questions. So I'm going to go over two questions, and I'm calling it reviewing concepts because I'm kind of hitting on some concepts we covered in the past. But these are specifically kind of just to remind you, like, oh yeah, dynamic program, let's look for ways we can build off of previous solutions and some recursion approaches as well. So the first one is called finding the minimum in a rotated or sorted array. So the whole idea is that you have an array And if it was sorted, it would just be 0 through 0, 1, 2, 4, 5, 6, and 7. And you will receive it and it'll be sorted, but with a twist. And the twist will be, it will start at a certain point. So here it starts at 4. And so with 4, it would go 4, 5, 6, 7, and then 0, 1, 2. And then you'll receive it in this kind of order. And so the question is, find the minimum element. And so for example, here, in the first example, we would know that 1 is the smallest. And then the second example, we would have 0 is the smallest. And then in the third example, we would have that again. We have several other examples, but I want to walk through. So this brute force approach that we would take would just take big O of n time. We would iterate through, and we know it would be increasing until we hit a point where it stopped increasing. We'd have 3, we'd have 4, 5, and then we hit 1, and this means we've found the smallest. So this is kind of a worst case scenario, and it's big O of n. And if we have hundreds of elements, and an example I'm going to show you how many decisions we would need to make if we did 10,000 different elements. So the question becomes, how can we improve our approach? And the idea is we want to use this divide and conquer. So we've used divide and conquer search. First, we did it to set up how we would perform a quick sort or a merge sort. And then we eventually used divide and conquer as the foundation of binary search trees. So what we do is we can divide and conquer. And we also have this idea, if you remember the longest increasing subsequence, where we use the divide and conquer to find the right place. So you remember from that longest increasing subsequence, we had 10, 1, 3, 2, 3, 4, and 5, right? And what we did is we started out is we created another array, and we had 10, and then we got to 1, and since 1 was less than 10, we just replaced that with a 1. And we had 3, since 3 is bigger than 1, we replaced it with 3. And I made the important caveat that we just had to find the length, not the actual value. So we had 2, 2 is less than 3, so we put 2 there. We had 3, I'm going to do 5 and then 4 here. So we had 5, and then we had to erase it to, I'm sorry, let me do 2 again. So if I do 2, and I had 5 here, then what we had to do is we had to go like this to update, to find the element to update. And we knew that the longest increasing subsequence had a length of 4. Once this got longer and longer, we used this divide and conquer approach where we just did minimum and maximums to go down and find the smallest element. Now, the crucial thing is that this was in order already from left to right. So if we tried this approach, what do we know? We would say we know the length is 5, so we can divide in half. And then we can say, well, if I know this, I can take the minimum or the halfway point on the left and the right. And here we know it's 5. We have 4 and we have 1, and 1 is smaller. So since 1 is smaller, we would go to the right. And then in this case, the maximum min would be the same, so we would find it. In a little bit of a bigger example, we would start at 7, and then what would happen is we would find the halfway point over here on the left and halfway point on the right here, and 5 is less than 1, so we go right. So then we would start with 1 being the middle element, and then we would take that divide and conquer would be 0 and 2. We know 0 is smaller, so we go left. And then we get to that max and min element, and we now know that we have found the smallest value. And so here's another one. In this case, we divide it, and we would get 4 on the left and 5 on the right, so 9 would be the middle element. 6 would be the middle on the left, 2 would be the middle on the right, so I'd go right. And I would just keep doing the same thing. we have 1 and 0, and I eventually find the smallest element there. So to kind of go back in the event that I went a little too fast, 2 would be the middle, so I'd go left and go right. And then 1 is smaller than 3, so we go left. Then 1 becomes in the middle, and we already have 2 over here, but 0 is now smaller, so now I can take 0 on the left. But now what I'd like to do is we're going to do a little twist. And if we were just taking this normal divide and conquer approach, this particular example would actually give us a wrong answer. And so let me show you why. We would start out, we'd go in the middle here. And what would happen is we would say we'd have 1 that's in the middle, 9 is on the right, and 4 is on the right. So in a normal divide and conquer, we would say, well, 4 is greater and 9 is greater and 1 is in the middle. Well, I don't want to go either direction because they're both greater. So therefore, we would say that 1 is the smallest element in the array here. However, we see that 0 is actually the smallest element in the array. So we see that this kind of initial divide and conquer approach actually causes us to get an incorrect answer. So let's try a slightly different approach and see how we can consider different scenarios if we run into this particular issue. So instead of just having 2, so we initially had these 2 elements, these 2 decisions, we're now going to have 4. So let me walk through each of these 4 choices, and you can see what those choices would be and why it is we would want to take these scenarios. So first I have test vec at min is less than the mid. So I have min is less than the middle point. So then I want to run the search in the max direction and run the smallest of the 2. Now the reason why I want to do this is because if I have min and mid, I also want to see if somehow we might have a smaller value over on the max side. And then we're going to do the same thing with max. If we see here with max, then we're going to run the search in the min direction and return the smallest of max and this returned result. The next 2 cases are going to be test vec at min equals the midpoint. Then we want to search at min minus 1 just to make sure we haven't accounted for anything over past min. And we're going to do the exact same thing for max, where we're going to do max minus 1. This is a typo. This should be min plus 1. So that's going to be min. We're going to move min over this way and then search here. Whereas with max, we would move it over this way and then search in that particular place. So now what I'd like to do is I would like to show you the code that I've developed. So it's min sort array. And so let me zoom in here and walk you through it step by step. So what I've done is I've templated it. And the reason I've templated it is that even though the problem states and it gives only integers, I actually wanted to test to make sure that I have it done properly. And so I've templated one of the vectors to a character just to make sure that I'm not unintentionally relying on specific values when I should just be looking at locations. So like with the other case that we did with search, we have the vector and we start with our min and max value. And just to review, the size of test vector returns alongside int because that is what we use to represent the location in memory. At line 17 here, what I'm doing is I'm just printing out the value at the current min and the current max. And what we're going to be able to see is the number of decisions that we need to make in order to be able to perform this algorithm. We see if min is equal to max, we just return the value at that location. That means we have found our solution. This is the base case to the recursive result. For line 23, what we do is we set the new middle point to be the max plus min divided by 2. And then I'm going to walk through my 4 cases. So I'm going to zoom in here, and I want to walk through the first case. So that we say the value at min in the vector is less than the value at the midpoint. Then what I want to do is I want to return the value, and that's going to be equal to this find min. It's a recursive call with the vector, which we've called by reference, and the new mid and the max. So we're checking to the right to just double check to be sure. And then here I use a ternary operator. So I compare the value at the min and this comp, which we've just returned. And I say, well, if that's true, we return min, otherwise we return comp. The second one is if I have test vec at max is greater than the midpoint, then I run min to see if I want to go in the opposite direction. And then I do the same thing. If the max is less than the comp, then I return that value at max, or I return comp. Then I have my 4 other cases. And what I have here is test vac at min equals the midpoint. So then I increment min by 1 in the recursive call, and I want to check to make sure that we've accounted for any potential in that range on the right-hand side. And then I say, well, if min is less than the comp that we've returned, then I do min or comp. And then I do the same thing, in this case at the else, we hit this if the max is equal to mid, at which point I check the min, where I subtract max minus 1, and then do mid there. And then I do the same thing with the ternary operator. I also, just as a review, kind of going over smart iterators, this is how I'm just going to print out all the values in the vector. And then down here in run test, I just say I print out the recursive calls. So find min is going to print the recursive calls every time I make a new find min call. And then I'm going to say the array, I'm going to print the whole array, and I say it has a minimum value of that result. And now in main, I've created 7 initial tests of all the different arrays that I showed you in the slides. And I did one with character. And then I run all 7 tests. Then last what I do, and initially what I'd like to do is I'm just going to make this 100. I'm going to set, I set an unsigned int and vector, which I call test large. And I say initial value is going to be 12. So it's going to be 12. And then I'm going to push that value back. And I'm going to keep going until I hit initial is equal to 100. And if that's the case, I set initial equal to 0. So the way this will work, let me bring up Epic Pen so you can see what it is that I'm doing here. All right, so it would be 12, 13, 14, 15, and so on, until we get to initial is equal to 100, at which point it would set it equal to 0, then it'd be 1, 2, 3. And here I do iter is less than 100, so that way I have a total of 100 elements in that array. So the whole goal is when I run that test, you'll start to see the benefit of doing the divide and conquer approach, because you'll see that there are fewer decisions that we need to make in order to find the smallest element. So let me run that test here. All right, then we exe min sort array. And we're now going to see that initially, when it's the smaller recursive calls, we're going to see that we have to make a decent number of calls, but that's because we haven't quite got the benefit of the log n as the size of the array grows. But we're still able to find that it's 0, that's 0. Here, the smallest one is 1. We see that we found 0, but the array length is starting to get longer, right? And we have min val is 2, and we see that I do 2, 3, 4, and then it rotates here 11 and 12. And here I have B is the smallest, and even though it's starting to, it's being somewhat consistent in the number of calls because the array sizes are about the same. So now what I have is I have an array length of 100, and we see that I went through 12, 13, it goes all the way up here. And I see that I quickly had found, oh, I didn't update it on did I not update it? I didn't update it. Okay, so I gave away the surprise, and the surprise is going to be that here I actually have I have 1,000 elements in the array, and I've only made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13 decisions. So our approach is very effective as the size of the array gets bigger. So what I was trying to do here is you press save, update on FileZilla. So initially, if it's just 100, it's relatively small number of calls. So we're not really picking up that many calls as we make it bigger. And so then it's 1,000, but let's make it, I'll even make it 10,000 here. So we can see that even as the size of the array gets significantly bigger, that our number of our decisions is not increasing that much. So you see here we go, we have 10,000 that we printed out, and I only had to make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 decisions. So that's significantly better than having a worst case scenario where I would have to search through 10,000 elements. So that is the benefit to this that particular approach. Okay, does anybody have any questions on that before I move on to the second question? All right, so let me quickly, so all the code is available, of course, on the GitHub page, and the code is also available here in the slides. There's the result, there's 100, then I moved it to 1,000, and we see the result there as well. The second problem is what's known as minimum window substring. Cancel. The whole idea is that we are given two strings, S and T, and our objective is to return the minimum window in which there's in S that contains all the letters in T. And if there's no such string, we return the empty substring. Note, if there is such a window, it is guaranteed that there will always be one unique minimum window in S. So that makes the problem a little easier. So here's an example. We have this Adobe code bank, and that's string S, and string T contains T, A, B, and C. And we see that here we have B, A, N, and C. And so that is the longest substring in this string that contains all three of these letters. Second one, we have A, and the output is going to be A. So when you're trying to think of potential solutions to these types of problems, the crucial thing is to try to find patterns. So you want to kind of try to go through the brute force approach first and see where patterns start to develop in the solutions. So if I would say, what's the smallest substring that begins at the letter A that's in blue, I would know that that is 6 because I'd have A, D, O, B, E, C. If I go to the next character D, that solution is going to be 8 because B, E, C, O, D, E, B, A becomes the shortest string after that. That's next. So this is the same thing. B gets there. And now I do E, that's code. And I do 6. And then we have 4 here. And then from here, it's not possible in that way. So here's another string where that has the similar pattern. And then here we see yet another pattern. And so let's see how we might want to build an approach to this. So let's take a first stab at it. And we're going to try to iterate through from the left to the right. And we're going to use a hash table. So we see that we might want to keep track. And so let's give it a try and see what happens. And then we're going to use this to see how we might respond when we don't have when our first approach doesn't quite go right. So here I would start at A, B, and C, and I update. I'm going to keep a count of all the elements. And what's going to happen is I am going to keep track. This count value is I would update this that has the number of characters I found in T in this current window. And when I say by a window, I mean I'm going to use two values. These are pointers that correspond to min and max. And min and max right now are both at 0. And so here's the interesting thing, and this is actually going to be very helpful for us when we encounter scenarios to try to, let's say if we have a B here, this would ensure that we don't unintentionally think it's 5. We would actually catch 4 correctly. So here's what's going to happen. I will say, well, I'm going to decrement A. So before it was at 1. And so let me go, this will be the first operation. We set min and max equal to 0 and count is equal to 1. I also have a global min and a global max where I've set it to 0 and infinity. Or in this case, if you're using a unsigned integer, you just make it the largest possible unsigned int. Then what we're going to do is we will keep moving the max until we hit another element. So now I hash B, and B had a 1 here, so I decrement its count, and then I update the global count. So now we are at 2. And we see this because we have A and B. And then I'm going to keep moving until I find a value here that is greater than 0. So if I had B here, I would actually make this -1. Well, let's keep going here. We get to C, and I've changed its count now to 3. I have now found all 3 values that were unique, and I've decremented the count in the hash, and then I have updated the local count. Now count is 3, which makes it equal to the size of this string. That means I want to compare min and max, and it's like, okay, well, 5 minus 0 is less than infinity minus 0. So now I want to update 0 and 5. And right now, this window has the current largest result. So now the next thing I want to do is I'm going to say, well, I'm going to start trying to move the left window by 1 here. So let's slide it over, and I'm going to update min. We're going to see min is equal to 1. And now since I have moved off of A, this means I no longer have all the possible characters in this window, which means the count has been decremented. So that's what I mean when I say decrement count by 1. But here's the interesting part. We want to increment the values count in the hash. And the reason why is here, this allows us to differentiate between if we have a place we want to stop and if it's a place we don't want to stop. And I'll show you what I mean in a moment. So what's going to happen is I'm going to say, well, I am going to keep, now I've moved it by 1. So now I'm going to keep moving max until I find a value that is greater than 0 in the count in the hash. So I keep going. So what do I do here? Notice that I've actually made this -1. this is going to be helpful to us later. And the reason why is because if I just said, well, I want to stop here, this isn't the smallest possible substring. It turns out that this would be because I have C, B, and A. So if we didn't do this, we would actually be getting a wrong solution. So this is why we are allowed to do negative values there. So we're going to decrement by 1, but because we're only moving max, we do not decrement count. So now I'm going to get to A, and we're going to see that A was previously 1. So I've now decremented the count to 0. And now I see that we have 0 and 10, I'm sorry, 1 and 10 in our array. So what we're going to do is we are going to move left until we find a negative number in the hash. And then we're going to see what we're going to do here. So we're going to say, now it's 0. And now we can check to see, we're going to keep moving here. We have a solution, but not a ideal solution. So now we're going to keep going. So now we're going to say, well, we're going to go with the left one. So we're going to keep going. And now we hit C. And we're going to see that we've now incremented C by 1. And since C has now gone from 0 to 1, this means we're going to move this one over until we decrement, until we hit one that we decrement. So now now it's back down to 0. And so what's going to happen is, well, now we found this. We're going to move off of C, and you're going to see that count's going to go down to 2. And then we're going to keep going until we find a value in the hash that is greater than or equal to 0. We have now found one at B. So now we have 9 and 12. So that means we have now, we're going to update our global max and global min, since 12 minus 5 is less than 5 minus 0. And then we would subtract it. And if we take that all the way to the end, it would give us our solution. So the last thing I want to do, I know I dismiss typically at 7. I just want to quickly go through another example just to make it clear as to what is going on. So same process. We initially set the min and max equal to 0. And so we're going to count here. And now what's going to happen is we're at A. For the sake of, let me, which one we're at? We're at 83. Hold on. I see the comments in the chat. Let's say this is Q. That should not have been a C. That'll make my animations and calculations correct. So here, what's going to happen is we're going to move because Q is not in the second string. And so we're just going to keep moving this way. So we're going to move min and max. So just pretend for the other animations that that's Q. So on that note, let me check the chat here. Where's the chat? All right, so thank you, Vinny, for sharing your experience. So these are everybody, sorry about that. So let me finish up this portion here. So here we now have our first element. So we have now decremented count in the hash here. So we got here, we decremented the count in the hash, but we have incremented the count here. So now we're going to start moving our maximum pointer. Now we've hit B, we've decremented in the hash, but we've incremented in the global count. And now we have C, so now we've hit 3. It was 1 in infinity, so now it's 1 in 6. So now we see that we have updated our global max. So now we're going to move the min over by 1. We're going to decrement count, and we're going to increment the count in the hash. And so we're going to start moving right. So now we've hit A, and now A is going to be incremented. And so now we're going to keep moving it. So now we have B, C, and now we have found the smallest one, CAB is here. And then what's going to happen is we're going to keep moving. BANC, that's 4. But now we know that 11 minus 8 is 3, 6 minus 8 is 2. So this will not unintentionally overwrite our correct answer. So this will take us through the end of the iteration. Okay, so does anybody have any questions before I dismiss? All right, well, on that note, you all have a wonderful evening, and I will see you in lecture tomorrow.